Hi, this is Kumar Singh from Designed Analytics LLC, and you're watching another episode of Maverick Mondays. Starting this week, since we concluded the brain-computer interface topic in the last episode of Maverick Mondays, we will get back to picking a fresh idea every week, unless we decide to again kind of focus on one area. But for now, it's one idea every week, right? So I kind of gave a sneak peek in a post this evening, earlier this evening, that it's going to be around building a real-time AI enabled platform that can help minimize pollution. Now, the underlying foundation of that thought process is around the huge pollution control towers that China has implemented. Now, if you take a quick pause here, if you look at the top, I would say 10 most polluted cities in the world, you'll see that most of them are in South Asia, actually, right? So we'll use the example of New Delhi to understand how this kind of a platform can actually make an impact, right? So I'm not sure, right, how exactly these towers work, but my assumption is that these towers are more generic, as in they kind of all have the same capability and work in the same way, thereby minimizing pollutants in the atmosphere. But the kind of pollution that each urban area might be experiencing might be different, right? So I think the first step here is designing towers that can actually flex depending on what kind of command it receives, and we will understand later where the command aspect comes from. So let's start looking at this picture, right? So there is this network of such towers which have varied capability, and they can actually filter pollutants based on the command they receive from a centralized AI based in the cloud. Now, the very first critical aspect would be to understand, okay, where should these towers go, where they should be installed, and what should be their capability, as in should these towers be specialized or should they be generic but with the flexing capability to address or attack certain pollutants when required, right? Now, the data points that you see here, I kind of shared a screen graph from one of the research articles. There could be satellite data, census data coming from traffic, buildings, weather, meteorological data. So plethora of data points that are already available actually in real time. So you set up the infrastructure for that, so that all the data, right, not only goes to a cloud, centralized cloud based infrastructure that hosts the central AI, but it also gets shared real time with these towers. Now the towers will work on the command from the centralized AI, but building this matrix of sharing information builds a redundancy in the network, right? Now start thinking about the data points. If you take the example of New Delhi, right, traffic, you would want to know, okay, what's the volume and density across the city, right? You know, what's the fuel composition of emission composition, right? The rate of emission across in a specific area. Those are the aspects that the sensors would capture, right? Sensors placed across street lights and other strategic locations, right? That's one example. Think about the environmental data. You would look for pollutant concentration, wind speed and direction, cloud cover and rainfall, solar radiation, visibility, Pascal stability, right? So those are some of the examples of environmental data. Then obviously geographical latitude, longitude, elevation, land use, land cover, a critical thing, right? There are, though considering the pollution level, people may find it difficult to believe, but there are huge green patches actually in New Delhi. Socioeconomic data is another critical factor. You want to know the population density, right? You want to know the urbanization rate of specific areas. And these are just examples. There will be more specific examples, but as you go through these data sets, you can already start imagining how all this data set, first of all, you decide based on this data whether you want to control towers to be specialized. If the pollution concentration, the specific pollutants in a specific area do not change right? Then you would want the control towers to be specialized in those areas. Otherwise, if it varies, then you can have the same I would say equipment that has the ability to flex based on command, right? Now, based on all this data that a centralized AI reads in real time, right? And the number of algorithms that AI will have to use will be more than one, right? It will be ANN, fuzzy logic, SVM, that's one aspect, like that's based on one solution that I thought of, right? It's a hybrid of like few different algorithms, but it will collect all that, analyze, right, and tell the tower exactly what needs to be done, how long it needs to run, what specific direction it needs to take, and everything, right? And will continuously monitor if there's an impact being made, right? Well, that's the infrastructure, that's the process at a very, very high level, right? It sounds simple at this level, it's going to be very complicated, but once a country has money to invest in this kind of infrastructure, it's a 24/7 thing that keeps on working for you and is kind of guaranteed to reduce the pollution level within a decade significantly if you are able to execute it in an optimal way, right? And imagine if you are a company, a provider who can build this seamlessly and prove the worthiness of this thing in one of the most polluted cities of the world, the amount of money that you are going to make, well, you don't have to guess it, right? Well, that's all for this episode of Maverick Mondays. I hope you liked the episode. Thanks a lot for watching. I'll see you again tomorrow.